Hey there, welcome everybody to the Daily Space Weather. We are looking at the closest star, otherwise known as the Sun, in 335 angstroms. It's this cool blue color, and we've indeed got a pretty cool sun right now, as we've seen solar minimum conditions return. We'll also be talking about our Patreon poll and ionospheric anomalies. Here's another wavelength. It's 304 angstroms, ionized helium. And we're seeing very weak solar activity, a small progression in the solar cycle, and some filaments still down here in the southern hemisphere. You can see one right there, a great view of that. Likelihood of coronal mass ejections is not all that high. Here's a diagram of the solar system. There's where things will be in 1 week. Here's a star chart. And you may see the Moon, Jupiter, and Saturn near the ecliptic if you're up before dawn. The radio flux only at 70 solar flux units. Again, solar minimum conditions have returned with 0 sunspots, which is this red line. It's a 1-year chart from Solon.info. The top line is the radio flux as the upper chromosphere and lower corona emit radio frequency, and it's the most proportional data set to sunspot number that we know of. 2800 megahertz is the frequency of that radio flux. We don't see any solar storms forecasted or anything like that. Again, very low levels of solar activity. And let's move into the realm of earthquakes. We are well past due for a 7 magnitude earthquake and indeed an 8 magnitude earthquake. Here is the Volcano Discovery current global seismic activity level. A great chart to show. Continuing on, here's the USGS map, and we'll just scroll up the list here. And we did see a nearly 6 magnitude quake happen in the past 24 hours, as well as a swarm there in Southern California. Leave us a comment if you felt any of those quakes. Also a deep quake at Chile at a 4.3 magnitude. A 5.5 near Tonga at the surface. Here's a 4.4 at Chile at depth. Indonesia saw a deep quake at a 5.0 magnitude. There was a 5.7 at Indonesia. A Peruvian deep quake at a 4.5 magnitude. And here we're back at Volcano Discovery. I like this graphic here, most recent earthquakes worldwide. You can filter by magnitude. I really enjoy this, and thanks to Mary Wright, one of our patrons and regular viewers. You can sort by 5+ magnitude, 4+ magnitude, and so on. Great resource there from Volcano Discovery. And let's check their Volcanoes Today page. Sakurajima is still erupting, producing an 8,000-foot ash plume. Subanosejima exploded. The size of the volcanic ash plume there, unknown. Taal in the Philippines, showing some ground deformation, a slow and steady inflation and expansion of the Taal region. This suggests persistent shallow magmatic activity beneath the surface, increased unrest, maintained alert level 2 at the Taal Philippine volcano. Tucono on Halmahera exploding, 8,000-foot ash plume there. A series of seismic swarms under the White Island volcano, just north of the North Island of New Zealand. No ejecta shown from there, although gas and steam emission plumes continue at stable levels since March. Revenador in Ecuador has been exploding, producing a 15,000-foot plume of ash. Sabancaya in Peru exploding, 24,000-foot plume of ash. Soufriere on Saint Vincent. Some mud flows occurred after a series of heavy rainfalls. As the National Emergency Management Organization noted, residents, especially in the yellow, orange, and red zones, should avoid areas within the vicinity of rivers due to destructive lahars, mud flows. Also, Piton de la Fournaise on the island of Réunion. Effusive activity slowed down on May 2nd and continues a declining trend. The main cinder cone continues to be active. Two main cinder cones continue to be active that have been building around fissure vents. The lava flow emerged mainly in lava tunnels, continues to advance slowly toward Grandes Pentes. The flow front on the southern flank has increased in 180 meters and reached approximately 1,500 meters elevation yesterday. The average lava flow discharge rate at the current eruption site is about 1.1 to 5.3 cubic meters per second. So quite a bit of lava coming out of Piton de la Fournaise, a prime example of why you should not attempt to pole vault the caldera. This public service message brought to you by smAsho.com. More on that later. And back to the sun-facing suite of instruments on the GOES 16. We did see two B-class solar flares here, aka very weak solar activity. No proton strikes on the GOES 16, and no surprises to our regular viewers there. The GOES magnetometer is looking pretty smooth over the past 3 days. And let's take a look at more magnetic data. Earth now in the South Pole current sheet shown here in red. No surprises there. Keep in mind the magnetic environment can suddenly change with basically no warning. Our channel might give you a warning if there's any data to back it up. Here's the line of sight ecliptic plane plot. Here's me learning to speak English. The line of sight ecliptic plane field plot. A different viewpoint of the same data, basically a three-dimensional imagery of the heliospheric current sheet. And here's the sun's B field in blue, and you can see it continuing to be pulled down here toward the south. That's a good thing. That's an indication that cycle 25's progression is actually a thing. You can see this western portion of the B field getting pulled down there toward the end of the video. That is what we see during solar cycle progression. As cycle 25 takes its time, we don't even really see any coronal holes right now on the Earth-facing portion of the solar disk. It's a featureless sun, basically. A couple minor active regions are all we see. The KP index at 0. No surprise there, but the weakened solar output. How about the real-time solar wind? We just saw a signal come in here. We just saw a signal happen right here. The temperature changed suddenly while we did show prep, and the solar wind speed dropped off, and the solar wind density came up. So it could be another pulse of coronal hole wind there. It's got some of the trappings of it. We also saw the phi angle shift at the same time. Anyway, current conditions are 5.45 protons per cubic centimeter. For the solar wind density, solar wind speed only 347 kilometers per second. Again, that's also solar minimum conditions. Magnetohydrodynamic pressure in the geospace. It's a 4 hours of geospace magnetosphere movie, and this magnetohydrodynamic pressure is looking like solar minimum conditions as well. Not the weakest we've ever shown, but pretty weak pressure in the geospace. A result of a low speed and relatively low density solar wind. We'll also show you ground magnetic perturbations. We show it daily on the daily space weather videos. Ground magnetic perturbations, geospace delta B. 4 hours of data of changes in the Earth's B field during this geomagnetic excursion. And welcome to the Neo-Renaissance. And the next thing we would do is welcome our Twitch viewers. Welcome to Twitch viewers. The URL for the rest of you is twitch.tv/smAsho. Twitch has a fantastic mobile app, by the way. It will alert you when we go live. We do most of our live streaming on Twitch, but we also do stream live to YouTube. Twitch.tv/smAsho. Twitch is a fantastic mobile streaming platform. It's good enough for gamers, and it's good enough for us, thanks to our new subscribers over on BitChute as well, bitchute.com/smAsho. Thanks to our YouTube subscribers. If you're viewing on YouTube, please don't forget to press the share button, as the algorithms, shall we say, dislike us. And this is our cosmology segment. So as always, some interesting stories in today's cosmology segment. Let's get to it. Would you like to buy a $1 million bottle of wine? Well, now this is a 2000 vintage. You may be surprised that a 2000 vintage would fetch $1 million. And I don't think it has fetched $1 million yet, but this wine went to space. And it's wine that's expected to have aged very well. Christie's said Tuesday it is selling a bottle of French wine that spent more than 1 year in orbit around the International Space Station. The auction house thinks a wine connoisseur might pay as much as $1 million to own it. 12 bottles were sent into space in November 2019. It's cosmic ray-induced wine, folks. If you'd like wine with increased cosmic ray flux, this wine has been irradiated for your drinking pleasure. And I believe this is a phys.org article. I'll just let the article scroll. The wine that went to space with the $1 million price tag. Let's talk about Steve. What does it stand for? Well, stimulated strong thermal emission velocity enhancements. Strong thermal emission velocity enhancements, otherwise known as Steve. It looks like an aurora, but it's really not. It's caused by rivers of moving particles emitting light the same way that the aurora emit light, but Steve is a different phenomenon. For some reason, it's associated with picket fence style auroras, as you can see here from an earlier astronomy picture of the day. This is today's NASA astronomy picture of the day for May 5th. Strong thermal emission velocity enhancements, otherwise known as Steve. Great view of a fantastically bright Steve. Great example of that. Again, associated with picket fence auroras, these horizontal parallel lines of auroras. Is that the Hall effect going on there in the atmosphere? Or should I say the mesosphere? Let's talk about radio emissions. Now what you're looking at here are 3 different redshifts. And this object is at a different distance than these two, most likely, as these two are at a redshift of 0.27 and 0.26. This one's at a redshift of 0.73, indicating that it's at a greater distance. It's an odd radio circle. Yes, the radio emissions from this series of galactic cores is odd. And radio astronomy is super interesting, folks. This is at 944 megahertz is the frequency of those radio emissions. And this is associated with radio galaxy NGC 253, known as the Starburst Galaxy. There's a great view of that. And we typically see radio galaxies are more viewed edge-on. They are less active in the X-ray spectrum and more active in the radio spectrum. Another article from phys.org, the odd radio circle. noted by the Meerkat Observatory, I believe. The Australian Square Kilometre Array Pathfinder, or ASCAP. So another interesting article there. Let's generate a random number. Today's random number is 819, which coincides with something at the Neil Gorell Swift Bat X-ray Observatory. The Burst Alert Telescope entry 819 is Ginga 1826-238, a low-mass X-ray binary / neutron star, a massive radio source. Probably in the southern hemisphere, as I've never heard of Ginga. In any case, there are the X-ray transient outbursts from this low-mass X-ray binary, and let's take a look at it on SIMBAD. We'll look at it in a few wavelengths here on Aladdin Light. We see a bit of an odd shape going on there. Let's take a look at it on the 2-mass. That's infrared spectrum. The infrared spectrum, this is the heat output from object also known as V4634 Sagittarii. Let's take a look at it in blue light. And there it is in blue light. We see some sort of a odd-looking structure associated with that. And it's apparently quite a bright X-ray source there, as shown by the XMM Newton. What are those odd loops there? We're seeing odd loops of X-ray output there near this object, perhaps associated with it. Pretty interesting. Let's see if it shows up on Pan-STARRS. And there it is on Pan-STARRS, one of the higher resolution pieces of imagery you might get of this object. Again, it's entry 819. Ginga 1826-238, the low-mass X-ray binary / massive radio source believed to be a neutron star. And here's yet another article about pulsars, as some new pulsars have been discovered. Here at the Smash News Network, least busted name in news, we're interested in pulsars. Rapidly rotating massive radio sources. This is an artist's rendition of one, as if you're viewing it from the pole. And stellar spots is one of the explanations of how these pulsars do what they do. This series is a study of some globular cluster cores. So apparently some pulsars being found, looking at 9 different globular clusters. New pulsars discovered in 6 of them. So this is a SciTechDaily.com article. This one will probably be all over the Science Wire as well, as the Meerkat Observatory discovers 8 new millisecond pulsars. Cheers, pulsars. And that's the end of today's cosmology segment. Thanks to our Twitch viewers, and wherever you viewed it, please share the videos on your social media. Tell your friends and foes about the channel. And we'll see you next time. And we'll invite you back Twitch for our meteorology segment. And let's continue on with the daily space weather with information about electron flux. So, the Earth has 2 primary Van Allen belts. During times of geomagnetic storm, we sometimes get a 3rd Van Allen belt, but most of the time we've got 2 Van Allen belts. And they are associated with all kinds of charged particles. They're surrounded by relativistic electrons. Here's a 1-year chart of the electron density. That's provided by solon.info/solar, by the way, if you want to look that up yourself. Don't take my word for it. Here's a 3-day chart of the electron flux, and we're seeing fairly moderate normal levels here. We don't see any charging hazards associated with that. Electrons out there in space, folks, they can charge up satellites. None of that currently going on. And here's the relativistic electron forecast model. We're expecting a small uptick here, according to NOAA, at least, in the next 24 hours, and then a slightly larger increase. I would not tend to disagree. I only try to forecast this when I have an idea what the forecast might be. And here's a visualization of the total electron content. This will show you where GPS errors are likely to occur. It's the total electron content between a GPS satellite and your handset, and it's a very chaotic series of electron shells here. very disorganized, especially around this portion right here. You can see large blobs of high-density electron regions even at nighttime. Most GPS errors occur around the equator at dawn. And here's a diagram of one slice of the atmosphere. It's just the Ionosphere layer. It's the vibrational frequency of that layer around 300 kilometers altitude. I wouldn't be surprised to see the ionosphere looking a little anomalous as well, and indeed it is. We're seeing charged up regions in the nighttime zone. And no real surprise there, as electrons allow for more chemical reactions to happen. There are a lot of ions up there that want electrons. So quite an anomalous ionosphere here, one of the more anomalous days that we've covered. Let's bring the latest image up. There's the latest image. For some reason, only at 4:45 Universal Time. It's like a 6-hour-old image. I don't know why it's so old. I've never seen that before. And again, that's around 300 kilometers of altitude. It's the Ionosphere layer. And next, welcome back to our Twitch viewers. We'll stream our meteorology segment live once again. Starting things out here at the Smash News Network, looking at nullschool.net. It's the surface winds of the eastern world. Now we've got a powerful anticyclone here in the southern portion of the Indian Ocean, that counterclockwise rotation associated with high pressure undoubtedly. And here are the jet streams of the eastern world. Quite chaotic jet stream flow once again, such as just off the east coast of Australia there. Some 180-degree bends in the jet stream. Here are the jet streams of the western world. Also very chaotic. We've got some backward jet stream here over northern South America, as well as a powerful anticyclone right here. A counterclockwise rotation in the southern hemisphere means anticyclone. And here is, by the way, Jupiter's Great Red Spot is an anticyclone, if you're wondering. Here are the surface winds. Powerful winds here continue south of Greenland, as we covered yesterday. Also a rift of calm winds, stretching all the way from Cape Cod, practically to the Azores. Continuing on, we saw some quite active lightning. I like to use lightningmaps.org when I hear thunder. And yowzers. New Orleans is surrounded by lightning. There's thunder rolling in Gulfport. So quite an active thunderstorm here, both east and west of New Orleans. Here's your global lightning map. Quite a bit of lightning on a worldwide scale right now. Quite a bit of lightning. And here's your U.S. GOES lightning mapper. Lots of lightning there around the Gulf Coast for the past 24 hours. Next, I wanted to look at snow depth real quick, since there's going to be lots of climate nonsense coming out thanks to the Communist News Network and other writers of sharticles. I just wanted to show you how much snow we have on Greenland. This is going to be a regular feature. Once a week or so, we're going to feature an article about how, oh my God, there's record melting in glaciers, probably because there's record snowfall, which is the mechanism that causes worldwide glaciation. It starts with snow, folks. Anyway, there's the snow depth of Greenland. It certainly doesn't look like it's melted yet. What do you think? Leave us a comment. Let us know. Let's check this area here. Oh, more than 5 meters of snow there. 5 meters of snow. 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 Continuing on, that's windy.com, by the way. By the way, please support our channel via our links. You can find our links at smashomash.com. One of our links is the smAsho merch site, and we've recently put up new merch entitled Vaccinate This. Since my vaccination status is none of your business, perhaps pick up some merch and tell your friends and foes about this. Yeah, my vaccination status is none of your business. It's the Health Insurance Portability and Accountability Act of 1996. Continuing on, back to climate. Check out the snow extent. Look how much snow is still on Central Asia. Yowzers. And I would note the snow extent tracker. The snowiest year that we had was actually 2018 to 2019. You can see this blue line here. That is the largest extent we've had on the entire graph there, going back to 2005. And we saw 4 years of snow mass balance, 2 standard deviations above normal. So this is clearly 2 standard deviations above normal, and we saw that for the winters of 2017 to 2018, 2018 to 2019, 2019 to 2020, and 2020 to 2021. 4 winters in a row featuring at least some point of 2 standard deviations above normal snow mass balance. So snow water equivalent still well above the 1 standard deviation blue line here, and we haven't even seen the spring melt really happen yet. Although snow extent is only 1 standard deviation above normal now for the entire northern hemisphere. Apparently, folks, it's so hot that it's cold. That's why it's so snowy. Has the North Polar ice cap melted yet? No. It remains frozen all summer every year. And look at the thickness of the ice off of the east coast of Greenland. We've got some areas there with over 4 meters of ice. You can see that red area right there. 4 meters of ice on the east coast of Greenland, adjacent to the Gulf Stream, which is what warms Iceland and the UK, if you weren't aware. And let's get back into some regular old meteorology. That was sort of the climate section here at the Smash News Network, least busted name in news. Not to be confused with the Climate Nonsense Network, the most busted name in news. Does your favorite online video content have a complete and total agenda? Well, this isn't an agenda. This is the U.S. Doppler radar map. Here's the cloud layer, and here's the water vapor. Again, cloud layer, Doppler radar, cloud layer, and water vapor. The water vapor map, folks, will give you insight into how things are going to move. For example, this dry air will provide a bit of a kinetic pulse, although it is being drawn a little bit to the south because this moisture is much less massive as the atmosphere attempts to reach static equilibrium. And that's today's meteorology segment. Thanks for tuning in, Twitch. We'll see you next time. And here are the bonus features for our daily space weather video. First, we'll show you the current hydrogen alpha imagery from the ground-based El Teide, Spain observatory, part of the National Sunspot Observatory. And again, there are still significant filaments down here, especially in the southwest. Likelihood for coronal mass ejection is still there, although not nearly as high as it's been. Thanks to our patrons, a true source of funding for the content. Patrons, please answer our Patreon poll. We put out a poll today about the releasing of the videos. Patreon.com/SmashoMash if you'd like to support the content. Thanks again to our patrons. Here are the rest of our bonus features coming in the form of the colorized magnetogram. So we see 0 sunspots. Here's an area of magnetic organization, not a sunspot. And here's the intensitygram, recently refreshed for your viewing pleasure. Again, 0 sunspots. We'll close things out with 2 more SDO videos. 2 full disk images of a rather featureless sun. Minor coronal holes there associated with the south polar region. 0 sunspots. It's 193 angstroms ionized iron. Here's another ionized iron ultraviolet light emission spectral state. 171 angstroms. Thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics, don't drink it. If you do, don't drive. Seriously, don't drive. Again, please support our channel. Press like, press subscribe, become a patron, purchase some merch. We'll see you next time at the Daily Space Weather. And may that solar wind be at your back.